Hello and welcome back to another video. Here in this video we are going to discuss another past year paper from Pure Mathematics 3, that is from October-November 2020, and it is 9709, component is 3.2. So let's start with question number 1. Here's question number 1. Solve the equation ln, that is natural log 1 plus e raised to the power minus 3x is equal to 2. Give the answer correct to 3 decimal places. So we have this natural log, so we can directly write it as 1 plus e raised to the power minus 3x is equal to e raised to the power 2. It's the natural log. So by definition also we can see, if it is log a base b is equal to c, then we can write a as b raised to the power c. So natural log means base is e, so it is e raised to the power 2 in this case. Now we need to solve for x, so we will transfer 1 to the another side and we'll get e raised to the power minus 3x is equal to e square minus 1. And now again let's take the log, or we can say the reverse process of this same thing. So we will get minus 3x is equal to ln of e square minus 1. So from here we'll get x as minus 1 over 3 ln of e square minus 1. So that's the answer, and we need to write the answer in the correct to 3 decimal place. So we will calculate this from the calculator, and that is minus 1 over 3 ln of e raised to the power 2 minus 1. This value is going to be minus 0.61819, so it is going to be minus 0.618 only, because next is 1 and 9, so this still 3 decimal places. This is the answer. I hope it is clear. Let's do the second question. Here's the second question, A part. Expand this in ascending powers of x up to and including the term in x cube. Simplify the coefficient. So we know the expansion of 1 plus a to the power n as 1 plus na plus n into n minus 1 over 2 factorial times a square plus n into n minus 1 into n minus 2 over 3 factorial a cube, and so on. So first of all we will convert this in this form, so it will become 1 plus 6x whole to the power 1 over 3 cube root, and hence here this n is 1 by 3, so this is going to be 1 plus 1 by 3 times 6x plus 1 by 3 minus 1 by 3, so 1 by 3 minus into 1 by 3 minus 1, and 1 by 3 minus 1 is going to be minus 2 by 3, so it is minus 2 by 3 upon 2 factorial, that is 2 into 6x whole square, it is 36x square. The last one, because we need to write till x cube, last one is 1 by 3 into minus 1 by 3 minus 1, so that is going to be minus 2 by 3, and minus 1 by 3 minus 2 would be minus 5 by 3. So upon 3 factorial, that is 6 into a cube, it means it is going to be 6x whole cube, means 6 cube is 216 and x cube. Now we are not required to write anything else because we require till x cube. So let's simplify it. These two got cancelled, it is 2, so it is 1 plus 2x, and it is minus here because it is minus and 2 got cancelled, and 3 3s are 9 and 9 4s are 36, so it becomes minus 4x square, and here it is minus plus, and 2 3s are cancelled now, and 3, and it is minus, so we'll write it as plus 5 upon 1 2 3 4 times 3 into 3 into 3 into 3 is going to be 81, and here it is 216. 16x cube, and plus and so on. We don't need to write that. So now we can simplify this also, and it is going to be 27. We will cancel it and we'll get 3, and here it is 8 times. So the final answer we got it as 1 plus 2x minus 4x square and plus 8 5s are 40 over 3x cube. So that's the answer. I hope it was okay. Let's do the B part. In the B part, state the set of values of x. We only need to state for which this expansion is valid. So we know that for 1 plus a to the power n, or 1 plus x also to the power n is valid only if modulus of a is less than 1. So here in this case it is 1 plus 6x to the power 1 by 3, and it is valid if 6x to the modulus of 6x is less than 1, or we can write x is, because 6 is a positive quantity, so modulus of x is less than 1 by 6. So this expansion is only valid if for the set of values of x as modulus x between 1 by 6, that is x between minus 1 by 6 to 1 by 6. Let's do the next question. Here's the third question. The variables x and y satisfy the relation 2 raised to the power y is equal to 3 raised to the power 1 minus 2x. By taking logarithms, show that the graph of y against x is a straight line. So this would be a straight line, and we can write the gradient form of a straight line is y is equal to mx plus c. So if somehow we can show that y and x is going to be linear and satisfying this type of equation, then it would be linear straight line, and state the exact value of the gradient of this line. So let's start with taking the log both the side. We will get y ln 2. We can take log base 10 also, but let's take a natural log. Ln 2 is equal to 1 minus 2x ln 3. We using the properties of log, that ln a to the power b is b ln a. I have used this, so it becomes y ln 2 is equal to ln 3 minus 2 ln 3 times x here. So we can rewrite it as y is equal to minus 2 ln 3 x over ln 2 plus ln 3 over ln 2. Now it is of the form, this is equivalent to y is equal to mx plus c, and hence it is a straight line. This implies y, graph of y against x is a straight line. It represents a straight line. So the question next part is the state the exact value of the gradient. So we can compare, m is the gradient, so gradient we can write, stating means only write the gradient. Gradient is going to be minus the coefficient of x in this way, so minus 2 ln 3 upon ln 2, or we can remove this and we can write this as 2 will go as the power of 3, so it becomes 3 raised to the power 2, that is 9, so it becomes ln 9 over ln 2. So that's the gradient. I hope it is clear. Let's do the B part. In the B part, find the exact x coordinate of point of intersection of this line with the line y is equal to 3x. So if we have two lines, it means solving the simultaneous linear equation. So we'll write both the lines here. Y is equal to, it was minus 2 ln 3 over ln 2 x plus ln 3 over ln 2, and the second line is y is equal to 3x, and we are going to solve it. I'll solve by substitution. Y is equal to 3x here, so I'll substitute it here, and it would be 3x is equal to minus 2, then it become ln 3 square, that is 9 over ln 2 x plus ln 3 over ln 2. Let me multiply complete equation by ln 2, we will get it as 3x ln 2 is equal to minus ln 9x plus ln 3, because these two got cancelled with this. So let's collect x from these two, and we will get it as x times 3 ln 2 plus ln 9 is equal to, because it was minus, so that side it would be plus, is equal to ln 3, and we'll use the log property, and it become 2 raised to the power 3, that is 8, and multiplication because it's addition, so it become ln 8 9 just 72 is equal to ln 3. So it means x coordinate in the exact form is ln 3 over ln 72. We are not required to solve it, and where a is 3 and b is 72. So let's do the next question. Fourth a part. Show that equation tan theta plus 60 is equal to 2 cot theta can be written in the form of this. So first of all, we need to know that tan 60 degree is equal to root of 3. Now we'll use the formula tan a plus b here, and we can write the left hand side as tan theta, that is tan a plus tan b, means tan 60 degree, over 1 minus tan a into tan b, that is tan theta into tan 60 degree, is equal to, left hand side is 2 cot theta, and cot theta is 1 over tan, so it becomes 2 over tan theta. Now we will cross multiply and use the value of tan 60 degree as root 3. We will get it as tan theta into tan theta, tan square theta, plus tan 60 root 3 into tan theta is root 3 tan theta, is equal to, let's cross multiply this to the other side also, so it will get 2 into 1, that is 2, 2 into tan 60 is root 3, so 2 into root 3 tan theta is minus 2 root 3 tan theta. So we'll translate it to the one side to get this form. It is going to be tan square theta plus root 3 tan theta plus 2 root 3 tan theta, because the other side it was minus 2 is equal to 0, or we got the final form tan square theta plus 2 plus 1 3 root 3 tan theta minus 2 is equal to 0. So that is what we need to write. Let's do the b part of it. B part is, hence solve the equation tan theta plus 60 degree is equal to 2 tan theta for theta between 0 to 180. So we will write from the first part, we can write this equation as tan square theta plus 3 root 3 tan theta minus 2 is equal to 0. So in order to solve this, we are going to simply solve this, and this is a quadratic in tan theta, so we can use the formula, quadratic formula, tan theta is equal to minus b, that is minus 3 root 3 plus minus square root of b square, that is 3 root 3 square is 9 3 is 27, minus 4 ac, 4 into 1 into 2, minus plus 4 2 is 8 over 2a, that is 2. It can be simplified further. It is going to be minus 3 root 3 plus minus 27 plus 8 is 35, so root 35, and we cannot simplify it, it's 2 here. So from here we got tan theta as these two values. So theta, two values of theta would be tangent inverse of, with plus sign, it is going to be minus 3 root 3 plus root 35 over 2, and with negative sign it is going to be tangent inverse of minus 3 root 3 minus root 35 over 2. So from the calculator, let's calculate what is these values. So this theta is 19.797 and theta from here it is going to be minus 79.797. And since we require the angle between 0 and 180 degree, so this is acceptable, but this is not acceptable, so we will check for the other angles from the tan. So other angles, we know that for theta, for any tan theta, the other angles is going to be either 180 plus theta or going to be theta only. So for next angle, the next angle from the 19.797 would be 180 plus, so that is going to be more than 180. So we are going to find the 180 plus minus 79.797 from here for the second value from this one. So it is going to be 100 plus the angle theta, that is minus 79.797. It is going to be 180 plus this, so it become 100.202. so it is going to be till one decimal place, it is going to be 2. So the two angles, the solution for this would be theta is equal to 19.8 degree and 100.2 degree. We can write 100 also because it is true till 3 significant figure, but that's fine because whenever we give the answer we need to give the angle till one decimal place. So that's the answer of it. Let's do the next question. Here's the fifth question. The diagram shows the curve with parametric equation x is equal to tan theta and y is equal to cos square theta. For theta in between minus half pi and half pi, show that the gradient of the curve at the point with parameter theta is this. So gradient for the curve is going to be dy over dx, and we can use the chain rule to find because it's a parametric equation. So dy over d theta will find and then multiply by d theta over dx, or we can say it is dy over d theta divide by dx over d theta. So let's find them individually. So dx over d theta is going to be differentiation of tan theta, and tan theta differentiation is sec square theta. And from y, dy over d theta, it is cos square theta, so differentiation 2 times cos theta, chain rule, and into the differentiation of cos, that is minus sin theta. So it become minus 2 sin theta into cos theta. Altogether now we will find dy over dx, the gradient of the curve. So dy over dx is minus 2 dy over d theta. Dy d theta is 2 sin theta cos theta over dx over d theta, that is sec square theta. And now 1 over sec theta is cos theta, so it become minus 2 sin theta into cos theta into cos square theta, so it become cos cube. So that's the gradient of the curve. Now let's do the B part. The gradient of the curve has its maximum value at the point P. So the curve has not the maximum point at P, the gradient of the curve has its maximum point at P. So we can take this as another function. Let's take y, or no, y is already there, so we can take it as, let's say, fx or f theta, because it's a function in theta. So gradient function we can take it as minus 2 times sin theta and cos cube theta, which is given in the previous part. Now find the exact value of x coordinate of P, and we know that x coordinate of P is x is equal to tan theta. So ultimately we need to find tan theta value, and it is given that it has a maximum value at P. So for maximum or minimum, we know that the differentiation or derivative of that function with respect to the parameter is 0. So here we need to find the f dash of t, derivative of this function with respect to theta. So it's a minus 2 and sin theta cos cube theta. So by the chain rule, product rule, we'll write it as minus 2 sine theta as it is. So next is differentiation of cos cube theta, and that is going to be 3 cos square theta, and differentiation of cos theta is minus, so I like minus here, minus sine theta, and plus I'll multiply this completely because minus 2 is a constant, so I'll take it outside, plus the second function as it is, and differentiation of first function, that is going to be cos theta, because differentiation of sine theta is cos theta, this, and for the maximum value of the gradient it should be 0. So we got it as sine theta, because minus 2 is a constant, so it cannot be 0. So minus sine square theta into cos square theta plus cos power 4, because cos cube and cos theta, it becomes cos power 4 theta is equal to 0. Or we can write it as I'll take this thing to the other side, or let's multiply by minus and rewrite it as sine square theta cos square theta is equal to cos power 4 theta. Let's divide the whole thing by sorry, here it is minus, so I forgot the minus, it is minus 3, so minus 3 here, minus 3, and now we'll divide by cos square theta, whole equation by cos square theta, so we'll get 3 times cos power 4 theta, so we'll get sine square theta cos square theta upon cos power 4 theta is equal to cos power 4 theta upon cos power 4 theta. These two got cancelled 1, and this 2 power will be cancelled, so we will left with sine square theta upon cos square theta is going to be tangent tan square theta is 1 over 3, or from here we can say tan theta is going to be plus minus 1 over root 3. But we can see from the graph this was something like that, and p was towards the negative side of x, so we will take the negative value of x. So x coordinate is tan theta, that too minus 1 over root 3, because it should be towards this side. So that is the answer, and that's it for this video. We'll discuss the last 5 questions in the next video. Till then, thank you so much.